Hey friends, Azure Static Web Apps is a service that automatically builds and deploys full stack web apps to Azure from a code repository. Apps are built and deployed based on code changes using GitHub or Azure DevOps pipelines, and Anthony Chu is here to show me how it works today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. I'm here with Anthony Chu. He's going to talk to me all about Azure Static Web Apps. How are you, sir?
I'm great. How are you, Scott?
I'm doing great. I'm actually really excited about Azure Static Web Apps because I've recently converted a bunch of my sites. I had some Razor sites, I had some Jekyll static generated sites, had a bunch of brochureware sites, and I had been running them all in a small Azure web app. I got rid of that. I'm saving money, moved it all to Azure Static Web Apps. I think about 9 of my sites now are Azure Static Web Apps.
That's awesome.
Yeah, I'm learning a lot.
Yeah, let's talk about static web apps then. So maybe let's start with talking about why static web apps kind of matter. So I think more and more apps now are built with front-end frameworks like React or Angular or Blazor, and a lot of the work that used to happen on the server side have now shifted to the browser, right? And these apps need very different hosting kind of capabilities compared to your ASP.NET or Express.js applications. We need to be able to serve static files really, really quickly. And ideally, we distribute this static content all over the world so that it's super close to your users. So when they try to access your site or your application, it loads really quickly. And Azure Static Web Apps is a service that's built for these types of apps. And at its core, Azure Static Web Apps makes it really easy to take your code from your local machine to a source control repository like GitHub or Azure DevOps. And every time you push a commit to your repo, we will automatically build and deploy your application to Azure. And as I was saying before, for your static content, we'll actually distribute that globally for you automatically. And if you need any, backend logic, you can optionally create a serverless API using Azure Functions. And you can source control that function app in the same repository as the rest of your web app, so they can build and deploy your entire application as one unit.
Yeah, it really shows a shift in philosophy. It's an interesting and different philosophy. Like I said, I had some sites that were mostly static with a couple of API calls to a back end. And because those applications they went from being very static to being a little bit active, suddenly I had to take them out of hosting in Azure Storage, and then I had to spin up a VM, or I had to go and think about hosting. But with this, you've got best practices, CDN, a scalable backend, all kind of codified into one service.
Yeah, absolutely. Should we do a demo?
Let's do it. I love demos.
Yeah. All right. So I have a pretty standard React application. It happens to show the weather. This is literally all the code that I wrote. I just used a widget that somebody else published. And then it's going to go and call an API that doesn't quite exist yet to grab the weather. So I think to start off with, let's look at how you would typically run this app locally. So it's a React app, so you would just start it by npm start. And then it's going to start up the React app server just to see what it does. And then it looks like it's open over here. So you can see that it has failed to load the weather. So that's a little bit sad. So we can add this API fairly easily. So I'll go ahead and stop this. And then using the Azure Static Web Apps extension in VS Code, I can actually go ahead and create an HTTP function in my application. It's like JavaScript. I can call this weather. Then it creates a function here that we can modify. So I've already done this, and I'll just paste it in. So all we're doing is that we're calling out to Azure Maps, which I just found out the other day has a weather API that I can call. And I'm just basically calling that API and then returning the content. You can actually do this from the browser as well, but I really want to keep my subscription key to myself. And eventually I might even want to allow logged in users to call basically to get the weather, but not anonymous users. So that's why I kind of have it in my function. And now I have both a function app that's on my machine as well as my React app, right? So typically to kind of test this out, I would have to start my React app and then start my function app and then figure out how they can talk to each other locally, because they're kind of like on two different endpoints locally. And then you have to worry about cores and all that stuff. So in static web apps, we actually ship a CLI to kind of make this really easy for you. To install the CLI, you just grab it from NPM and just NPM install this thing. And then we now have a CLI.
The CLI command line interface. So now, like, you typed NPM this and NPM that, I can do something with Azure Static Web Apps at the command line.
Yeah, so now I can type the word SWA.
Static Web Apps.
And then I have, basically a command line that I can start up. I actually forgot one thing, is that my app requires like a library to actually talk to the to the API. So I'm just going to quickly install that. So npm install Axios. So we support, installing packages and stuff as well.
Sure. And Axios is what you're using to do that HTTP GET.
Yep.
And it looks like you're just calling that at that Azure Maps API and then just brokering the call back to your static web app.
Yeah, exactly.
Okay.
Yeah, so to kind of like start this whole thing up all at once using the CLI, we just have to type out a command called SWA start, and I have to tell it the local endpoint to proxy to for the React web server. So that's localhost 3000.
So it's kind of a simulator, a static web app simulator?
It's a simulator. And later on, we're actually going to look at how we can simulate authentication with it, which is really difficult to do locally otherwise. And then we can basically pass a run command. So npm start was our run command, as we saw earlier. And then I also want to tell it where the API lives. So it lives in the API folder. And just this command alone should start up everything that I need. So both the React dev server, as well as the Azure Functions core tools that runs my function app locally. And then it gives me a single endpoint that I can call locally at port 4280. So now if I switch back over to my browser and I go to port 4280, you can see my application. And because it made it was able to call the API, it now returns the weather. So
this, I think I understand here. So 4280 is simulating Azure, returning the static part of the stuff, and then the actual NPM, the JavaScript application, is running on 3000. So this is our kind of our index.html. This is our endpoint for our application, and when you put it up in the cloud, it'll be at whatever domain you want.
Yeah, and then anything that is at /API/something, so at /API/weather is going to be routed to my function app. So this is the result of my function. So they're both under the same domain, just like it happens in the cloud.
Just like it happens in the cloud. Isn't that cool? That does, dealing with multiple services locally like that, all the different local hosts and the ports can be very confusing. That's a very nice way to make that simpler for everyone.
Yeah, absolutely. So now let's take a look at how we can actually deploy this to the cloud. So I'll stop my app. And then using the same VS Code extension, the first thing I need to do is actually make my commit. So I can add API, it's committed to Git. And then I will use the Azure Static Web Apps extension and say, create static web app. I choose my subscription. It's going to ask me if this is really the branch I want to use. I say, sure. Oh, and it wants to reload the window. Fantastic.
I think your extension just kind of updated itself as you were doing some stuff.
Yeah. Let's try this again. Continue. And this time, hopefully, here we go. It's going to ask me for the framework that I'm using. So what this is allows us to pick some presets for some settings so that you don't have to kind of figure it out yourself.
That's a pretty comprehensive list.
Yeah. So and this is not all the things that we support. We actually support pretty much anything that can compile, especially in JavaScript, as well as something like Blazor. And you mentioned Jekyll and Hugo before, so we support all those. So basically we have to give it a couple of things, a couple of pieces of information. One is, where does my app live? And it's just living at my root. So I'll just say that. And then also where is the output of my app? So when I run npm run build, which is what the service is going to do on my behalf, it needs to know kind of like where the app is built to. And depending on the framework, it lives, in a different location. So for React is in the build folder. So if I press enter, this will actually go and create my static web app for me. But I've already done this, so I'll kind of show you what it looks like. So this is an app that I've already deployed. It's the exact same app. So when I actually go ahead and kind of finish the deployment process, what Azure does behind the scenes is that it creates a GitHub workflow for me to deploy my application. It automatically kind of creates this file based on what I kind of enter there in those boxes. Mm-hmm. And then every time there's a commit to my branch or any pull requests that are created against my repo, this will fire, and then your app will build, and then it gets deployed. So if I go back to my code, I can actually take a look at the GitHub action that gets run. So this is the GitHub action that ran, and it deployed it to the cloud. And if I scroll all the way down to the bottom, it has the URL that I can click on to actually see the site that was deployed to. So it's actually using the app is using the browser's location API to figure out where I am to get the weather for me. And there it is. I also have a custom domain created as well for it. So my app is under weather.anthonytree.dev. And if I go there, I have a site that is using this custom domain. And Azure Static Web Apps actually provides a free SSL or TLS certificate when I add a custom domain. So I don't have to do any extra work to manage my certificates.
And that's a thing that I know that I'm super excited about, because I've got babysmash.com and like all these like little projects that I do on the side, and we're moving to an HTTPS all the time environment. Chrome and soon Edge are going to basically default to HTTPS for everyone, and certificate management for small hobby sites are no fun. And I love that Azure Static Web Apps, by managing that certificate for you, just makes our lives so much easier. I was honestly spending time all the time with let's encrypt certificates and background jobs and anything I could do to just make sure that my sites were secure. And that's gone. Azure Static Web Apps handles it all for me.
Yeah, absolutely. Yeah, that's one of my favorite features as well.
Awesome.
All right, so let's take a look at a couple of more advanced kind of things. So, like I was saying before, maybe it would be nice to only allow an authenticated user to access my API. And Azure Static Web Apps has authentication built in. So, out of the box, we support things like Twitter or GitHub or Azure Active Directory. Or you can actually plug in any OpenID compliant, OpenID Connect compliant provider, and we basically handle the login for you. And then what you can do after that is you can actually restrict, access to routes and things like that using, whether the user is authenticated or not, or even using roles. So to do that, I'm actually going to switch over to a branch that I've already done this on. Mm-hmm. And to do that, we just have to add a file called staticwebapp.config.json. So this file, you can actually use it to configure a bunch of other stuff as well. So anything related to auth. So like I was saying earlier, if you want to set up different auth providers, this is where you do it. If you want to do, return global headers, if you want to have supporting custom headers, MIME types, or do any kind of networking stuff, you can do it all in here. And then I just want to point out a couple of things that I have in here. So one is this thing called the navigation fallback. So a lot of these frameworks do client-side routing, and when the routing happens client-side, and somebody takes this, the route that they copy from the location bar, and then they kind of give it to someone else, or they reload the page, on the server, the thing that's serving your static assets actually don't know anything about your client-side routes. So pretty much all the frameworks like React or Angular or Blazor or Vue requires what we call a navigation fallback. So no matter where you navigate to, we want to serve the index.html. So this is kind of like the rule that you would put in here for that. Mm-hmm. And then we can also apply rules based on for specific routes. And here I'm saying that anything that's hitting the API endpoint is only going to allow authenticated users to access. So to run this, I've actually configured this version of the app to actually launch from VS Code. So what I can do here now is I go over here and press basically F5. It's going to run that same command that we saw earlier that I ran, but I've kind of configured VS Code to start this. So now both the React Dev server is going to start, as well as Azure Functions Core Tools, and the Static Web Apps CLI. So pretty soon, hopefully, the site will load here. Give it another second or two.
You have to hit refresh a couple times.
Yes, we do. So basically what happened is I have a little bit of extra code in the app that says if I hit the API endpoint and it says unauthorized, please bounce the user to the Static Web Apps, basically a built-in login endpoint. In this case, I bounced them to the GitHub endpoint. The font might be a little small, so you might not be able to see it. So in the cloud, when this runs, it'll actually make you log in using GitHub. But locally, you don't really want to configure this. So what we actually decided to make it possible to do is you can just pretend to be anybody you want because you're just running locally. So if I want it to be you or if I want to be somebody else, I could just basically punch in the information here and click login. And now I'm logged into the app and I have access to my API.
Nice. That's great for testing locally.
Yeah, and I can also set endpoints as well, or sorry, breakpoints as well. So if I actually just quickly kind of go in here and drop a breakpoint here in my function app, I can go into even my little weather app and drop a breakpoint somewhere in here. Hopefully this will get executed. So if I actually go back to my page, if I hit reload, it's actually hitting a breakpoint that's in my client-side JavaScript right now in my React app. And then if I press the little play button, it's now going to hit the breakpoint that's in my Azure function. So basically, you can now attach a debugger to both your front end and your back end and debug them together locally.
That's pretty slick. Being able to simulate the cloud locally really makes things easier when you go to production.
Yeah. And then if I wanted to kind of take these changes to the cloud, I can go ahead and create a pull request. And I've already kind of done that here, so we don't have to kind of wait for that to happen. But you can see that I've pushed this branch up and I created a pull request. And what we do for pull requests is that we will actually stand up a staging environment for you that is temporary for the lifetime of your pull request. When you close your pull request, we'll delete this environment. So you can see that I can actually go ahead and navigate to my staging environment. And I believe the staging environment has the GitHub auth enabled, or it doesn't. I think I'm logged into GitHub already. So
right, you're already logged in.
So you can quite see that.
Right.
But yeah, so you can trust me that it actually worked. That it would redirect me to GitHub and actually then login.
And that's another great thing that Azure Static Web Apps offers for a CI/CD environment is like if you and another person are working on something and they can see in the PR the staging site, it really accelerates that developer loop.
Yeah, absolutely.
Very cool. I'm loving it. I love Azure Static Web Apps. I mean, people are sleeping on this and they need to one of the great things about Azure Friday is you can show something to someone and they should, hopefully, if we're doing our jobs, either pause or when it's done, go, I need to go and make this happen right now. Like I need this to just stop everything. And when I heard about this stuff, I started just changing my sites over immediately. And I had, virtually no downtime to move these things over from Azure Web Apps to Azure Static Web Apps. So now my personal Hanselman Incorporated is a combination of functions and static web apps, and then Azure App Services for my more complicated sites.
Nice. All right, so a great place to learn about how to build your static web apps is at Microsoft Learn. We have quite a few modules, so many that we actually built a learning path out of it. So anything from learning to just get started, as well as learning to add an API, or how do you authenticate users, or even learn how to deploy an entire Blazor WebAssembly app to Azure Static Web Apps. That's all here for you to try out.
Oh, fantastic. This is great. gush. I know I gush sometimes, but I gush about Azure Static Web Apps because it's just that perfectly sized screwdriver in my toolbox that allowed me to go and make my sites just that much better. And I would really encourage people to check it out. Thanks so much for hanging out with me today.
Yeah, thanks for having me, Scott.
I am learning all about how to get started with Azure Static Web Apps today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.